What is partitioning? Partitioning is the process of separating data into logical subsets. In the same way as normal tables and indexes, partitions are physical segments for which extents are allocated. Partitioning offers these advantages. It enables data management operations such as data loads, index creation and rebuilding, and backup and recovery at the partition level, rather than on the entire table. This results in significantly reduced times for these operations. It improves query performance. Often the results of a query can be achieved by accessing a subset of partitions, rather than the entire table. For some queries, this technique, called partition pruning, can provide order of magnitude gains in performance. It significantly reduces the impact of scheduled downtime for maintenance operations. Which objects can be partitioned? Tables and indexes can be partitioned. All combinations are theoretically possible. Table not partitioned, relevant index partitioned. Table partitioned, relevant index not partitioned. Table partitioned, relevant index partitioned. Up to 64,000 partitions are possible. Objects with long fields and long raw fields cannot be partitioned. What are the advantages of partitioning? Improved administration because many operations can be carried out on separate partitions, data loads, index creation and rebuilding, backup/recovery, and so on. Partitions that are no longer required can simply be dropped, no reorganization to recover disk space, and no time-consuming deletes are necessary. You can improve the performance of queries if only specific partitions have to be read. Partitioning is transparent for the application and does not require any change to SQL queries and DML statements. Avoid redo log data when you delete old data because, unlike a delete, a drop, or truncate does not generate redo log data. What problems can occur in connection with partitioning? ORA 014508. Validation of partitioned objects with validate structure encounters an ORA 14508 error if the utlvalid.sql script was not executed for the executing database user. To avoid the error, see note 514178 and execute utlvalid.sql for all relevant users. ORA 14400. ORA 14400 occurs if you want to insert an entry in the table that does not match the value range of any partition. In such a case, you must compare the value of the entry with the definitions of the partitions to determine the cause of the error. Queries that do not contain the partitioning criterion in the where clause must scan all partitions. In these cases, the effort increases in proportion to the number of partitions. How many types of partitioning exist? Range partitioning. Each partition includes data from a specific value range, for example, column year, January 1, 2002 to December 31, 2002 partition 1. Column year, January 1, 2003 to December 31, 2003 partition 2. Column year, January 1, 2004 to December 31, 2004 partition 3. List partitioning. For each partition, there is a list specifying the values to be assigned to this partition, for example, column country, Germany, France partition 1, Europe. Column country, USA, Mexico partition 2, America. If you specify a default partition, all records that do not match any list are included in this partition. Hash partitioning. A hash algorithm is used to distribute the records at random to the individual partitions. Combined partitioning. Several of the above partitioning types can be combined in the form of partition and subpartition, for example, range hash or range list. Composite partitioning. Composite partitioning combines two partitioning methods to further divide the partitions of an object into subpartitions. The methods available for composite partitioning are 11G, range, list, hash, list, list, hash. The following different partitioning methods are used in relation to indexes. Local partitioning. There is a 1:1 relationship between the table and index partitions. Each index partition contains the values of exactly one related table partition. Global partitioning. The index partitioning is independent of the table partitioning in question. An index partition can contain values from different table partitions. What is the Oracle syntax for creating partitioned objects? Example of range partitioning. Create table months, month number, days number. Partition by range, month. Partition winter values less than 4. Partition spring values less than 7. Partition summer values less than 10. Partition autumn values less than 13. Example of list partitioning. Create table months, month varchar, 20, days number. Partition by list, month. Partition winter values, January, February, March. Partition spring values, April, May, June. Partition summer values, July, August, September. Partition autumn values, October, November, December. Example of hash partitioning. Create table months, month varchar, 20, days number. Partition by hash, month. Partitions for. How can I find out which objects are partitioned? The following statement provides all objects with partitions at Oracle level. Select table underscore owner, table type, table underscore name. From DBA underscore tab underscore partitions. Group by table underscore owner, table underscore name. Union. Select index underscore owner, index underscore name. From DBA underscore IND underscore partitions. Group by index underscore owner, index underscore name. How do I determine all the partitions of a partitioned object? You can receive the partitions of a table as follows. Select asterisk from DBA underscore tab underscore partitions where table underscore name equals table underscore name. You can determine the partitions of an index as follows. Select asterisk from DBA underscore IND underscore partitions where index underscore name equals index underscore name. Where does Oracle store administrative information for partitions? Oracle stores administrative information for the partitions in the DBA underscore part underscore tables and DBA underscore part underscore indexes views, for example. Partitioning underscore type, partitioning type. Partition underscore count, number of partitions. Def underscore asterisk, default values for memory and configuration parameters, see note 666061. The DBA underscore part underscore key underscore columns view contains the columns to which an object is partitioned. Name of the partitioned object. Column underscore name, column name. Column underscore position of the column during partitioning. The DBA underscore TAB underscore partitions and DBA underscore AND underscore partitions views contain the high value of the partition, in other words, during range partitioning, the value that was specified with less than. High underscore value, high value of the partition. How to determine whether an index is global or local. To determine whether an index is global or local, query the column, locality, in DBA underscore part underscore indexes. Why do indexes on partition table become unusable? By default, many table maintenance operations on partition tables invalidate, mark unusable, the global indexes and affected local index partitions. At partition maintenance of the table, all partitions of a global index are affected. You must then rebuild the entire index or each of the affected index partitions. What happens when row movement is enabled? If enable row movement is set, it means that the record is deleted at the old place and inserted again at the new partition. And this is done in the context of the current transaction. So the records can always be found in just one clearly defined partition. This causes certain overhead, since we are speaking two DML operations, delete, insert, instead of one, update. From experience I can say that this overhead is acceptable if one record is processed at a time. However, if we are dealing with a mass update, in which records are perhaps also changed in parallel with high frequency, then this overhead will be very disturbing. Thus, the question is whether such a mass update will occur regularly in the course of standard processing, or whether it will be an exception. You can probably live with an exception, as you can disable the row movement for a short time. If mass updates occur regularly, the row movement must be forbidden, and process datasets must be stored in the processed partition awaiting a dedicated maintenance operation. Although most of the rows that have been processed will still be found in the processed partition, the advantages of the clean room strategy defined above will only be partially available. How to gather statistics on large partition tables in Oracle. It is difficult to gather stats on large partition tables, which is huge in size. For such tables we use to gather statistics of one partition, which we can call it as a source partition, and copy that stats to rest of the partition, which we can call it as destination partition. For example, if you have 366 partitions, then you can gather stats for any one partition, say P185, and now copy stats to rest of the partition. Please note that, choose the partition where you have data in that partition. There is no need to gather stats for all the partition because Oracle internally distribute the data based on the partition key. Step 1, gather stats for any one partition, say P185. Step 2, generate script for rest of the remaining partition like shown below. Your source partition will be P185 and destination partition will be rest of the remaining partitions. Step 3, after gather statistics you can lock the stats. Using below format you can generate the script for all the partitions after making necessary changes. Explain gathering statistics on partition tables. When gathering statistics on partition tables, it is important to know the difference between table level and partition level, and, if applicable, sub-partition level statistics. The optimizer will use partition level statistics if the query predicates are on the partition keys. However, if the query predicates are not on these columns, or even if on the partition key do not allow for pruning to a single partition, the optimizer relies on table-level statistics. Analyze what aggregate table-level statistics from partition-level statistics. DBMS_stats allows gathering of both or either statistics. Case 1, statistics were collected with granularity as partition. Exec dbms_stats.gather_table_stats, sh, sales estimate %% equals 100 granularity equals partition cascade equals true, no _invalidate equals false. Case 2, statistics were collected with granularity as all. Exec dbms_stats.gather_table_stats, sh, sales estimate %% equals 100 granularity equals all cascade equals true, no _invalidate equals false. Let's compare the two runs. The first run of queries is with granularity equals partition. In this case, for the EMP_ID, Oracle estimates 3019 distinct values and no histogram. It actually did not gather statistics based on any sampling of EMP_IDs. For the query on EMP_IDIN 10-100-1001, Oracle estimates a cardinality of 961 rows, while the actual count is 352 rows. The second run of queries is with granularity equals all. Here, for the EMP_ID, Oracle estimates 7,059 distinct values, based on a sampling of 918,843 rows. It HSA not yet created a histogram. For the query on EMP_IDIN 10-100-1001, Oracle estimates a cardinality of 390 rows, which is closer to the actual count of 252 rows. Thus, although gathering statistics only at the partition level may make sense where your query predicates are always based on the partition key and partition pruning can happen. Table-level statistics are necessary for queries where partition pruning cannot be done. It's important to point out that partition or sub-partition level statistics only get used if the optimizer is able to prune to a single partition/sub-partition. Otherwise, the next level statistics, partition/global, will get used. How does exchange partition works in Oracle? Exchange partition command can exchange partitions in a list, range or hash partition table. The structure of the source_table must match the structure of the target_table. Both tables must have matching columns and data types, and the data contained within the table must adhere to the partitioning constraints. How to split a partition? Single large partition can be split into smaller partitions as required. Alter table big_table. Split partition big_table_2007 at TO_date, December 31, 2005 23:59 and 59 seconds, ddmon YYYYHH24 DMISS. Into, partition big_table_2005. Partition big_table_2007. Update global indexes.